All right, I'm going to make this video on making equivalent fractions using division. Okay, so I just wanted to go over. Let me start with the fraction 6/8. Okay, so if we have 6/8, all right, first thing I want to do is I can show a model. All right, so I'm going to show a rectangle. I'm going to split this up into eighths. All right. I now have eighths, all right, because we know my denominator shows me number of equal parts, all right, number of equal parts, and then my numerator is going to be the number of parts. I guess you could say the number of parts we're looking at. Number of parts. I'm going to put number of parts shaded. Okay? So if I have 6/8, 1, 2, 3, 4, 5, 6. That is 6/8. Okay? So now, how can I write an equivalent fraction using division? Well, what I'm going to look at here is, and I'm going to take a different color. I'm going to take blue, all right? And I'm going to make it a little bit thicker, all right? And I'm going to say, instead of having 8 parts, all right, how can I group some of these parts together, all right? Can I split this rectangle up into equal parts, but I want the parts, I want less than 8. So I could look here and say, I could group 1, 2, 3, 4. 1, 2, 3, 4. So I now have 4 equal parts, all right? So my denominator is now, so I had 6/8, is now going to be fourths, all right? And now, how many parts do I have shaded in? Well, I have 1 whole part shaded in, 2 whole parts shaded in, 3 whole parts shaded in. So I have 3/4. Now, how do I get from 6/8 to 3/4? Well, what I could do is, how could I get from 6 to 3? And remember, whatever I do to the numerator, I do to the denominator, all right? So if I'm thinking division, what can I divide 6 and 8 by? And my trick is, ask yourself, what kind of number is 6 and what kind of number is 8? What number can I divide into 6 and divide into 8? Well, whenever you have an even number, which we have an even number on the numerator and an even number on the denominator, we could always divide it by 2. 6 divided by 2 equals 3. 8 divided by 2 equals 4. There we have 3/4. That is how we could use division to find an equivalent fraction. So now, let me try another fraction. So let's say we have 9/12. All right? I'm going to do the same way. Let me make a rectangle. And I want to, if you have to show the model, show it. Or you may not have to show the model. You could just use the standard algorithm. But I'm going to show the model first. So first, I look at my denominator, which is 12. 2, 4, 6, 8. I go here. All right? 2, 4, 6, 8, 10, 12. There's 12. I'm sorry for the clicking in the background. It's the heat. That's 12 pieces altogether, so 9 out of 12. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 9/12. Okay? That's how I could represent 9/12. Now, how can I represent 9/12 as an equivalent fraction using division? Well, what can I divide? What can I make these into groups of? Well, let me see what I did The last time I split them into groups of 2. 2, 2, 2, 2, 2, and 2, 4, 6, 7, 8, 9. Well, no, I'm grouping what I shaded in together. I only have one shaded left. I can't make a group of 2 shaded. So I can't do that. I can't group them into groups of 2 because then what's shaded, I can't shade in a full group of 2 all the way across the whole diagram. So let me try groups of 3. Now watch this. 1, 2, 3 in that group. I could do 3 in this group. 3 in this group and 3 in this group. Was I able to make equal groups? Yeah, I was able to make 4 equal groups. Well, how many of those groups are completely shaded in? 1, 2, 3. 9/12 equals 3/4. Now you want to say to yourself, well, how can I get from 9 to 3? Or what can I divide 9 by and also divide 12 by? This is where you need to know your multiplication facts, because you have to say, what times 3 times what gives me 9 and 4 times what gives me 12? Well, I know I could divide them each, that 3 goes into 9 and 3 goes into 12. 9 divided by 3 equals 3. 12 divided by 3 equals 4. So 9/12 equals 3/4. Now, that's how we can do showing a model. All right? Now, let's say we don't have a model. All right? Let's say you get the fraction 15/20. Okay? 15/20. How can I make an equivalent fraction using division? What can I divide 15 by and also divide 20 by? Well, I say to myself, can I do 15 divided by 2? Nope, 2 doesn't go into 15. So I can't divide them both by 2. 3, well, 3 goes into 15 evenly with none left over. But can I do 20 divided by 3? Nope, 3 doesn't go into 20. But 15 and 20, 5. 5 goes into 15, so I can do 15 divided by 5, and I can do 20 divided by 5. So, what is 15 divided by 5 equals 3, and 20 divided by 5 equals 4. So 15/20 does equal 3/4. And if you show your model, you will get the same thing. You'll get 3/4. Now, you may get, when you're just looking for an equivalent fraction, you can get different answers. Like, for example, if I had 6/8, all right, I'm going to put 6/8 twice over here. 6/8. So 6/8, I know they're both even numbers. So I can divide 6 by 2, and I could divide 8 by 2. So 6 divided by 2 is 3, and 8 divided by 2 is 4, and you get 3/4. Now actually, that is true, so I'm just going to give that as an example, but actually there's no other way there's no other equivalent fraction using division. So I'm actually just going to leave that as a practice example, right? 6/8 would be equal to 3/4. I may have even done that one before. What I wanted to look at was this. What if I said 10, I apologize for that, I just don't want to start over, 10/16, okay? 10/16, or actually, nope, that's a bad example too. I want to do let's do this. Let's try. I'll try one last time. 12/14. All right? Because you could say, well, that one doesn't work, but sorry, this is what happens when you try coming up with them off the top of your head. But right here, if we were to do 12/14, once again, 12 is an even number, and 14 is an even number. So I would know I'm going to divide them each by 2, okay? 12 divided by 2 is 6. Okay, 12 divided by 2 is 6. And 14 divided by 2 is 7. So you would get 6/7. All right, 6/7. Works out. Okay. And that is actually where I'm going to stop now. I apologize. I'm trying to think of an example off the top of my head, but I'll be better off in another video showing that equivalent fractions can be represented in many ways. So I'm just going to leave it at that. So I hope you found this video helpful.